Science and technology. Scientific study. Scientific study is the process of acquiring knowledge and understanding of the natural world through the scientific method. It involves a systematic and objective approach to studying and investigating the world around us, using empirical evidence and logical reasoning to draw conclusions and make predictions. It is conducted using a rigorous scientific method that involves selection of research questions, setting objectives, asking questions, formulating a hypothesis, designing and conducting experiments or observations, collecting and analyzing data, and drawing conclusions based on the evidence. Scientific studies include scientific facts, theories, scientific models, applications and physical conditions. Steps of the scientific study. One. Observation. When we see any event around us, some curiosity will arise. To know about it. Two. Ask a question. The scientific study starts when you ask a question about something that you observe. How, what, when, who, which, why, or where. For a science fair project, some teachers require that the question be something you can measure, preferably with a number. 3. Do background research. Rather than starting from scratch and putting together a plan for answering your question, you want to be a savvy scientist using library and internet research to help you find the best way to do things and ensure that you don't repeat mistakes from the past. 4. Construct a hypothesis. A hypothesis is an educated guess about how things work. It is an attempt to answer your question with an explanation that can be tested. A good hypothesis allows you to then make a prediction. If, blank, I do this, blank, then underscore 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 underscore, this, blank, will happen. State both your hypothesis and the resulting prediction you will be testing. Predictions must be easy to measure. Five. Test your hypothesis by doing an experiment. Your experiment tests whether your prediction is accurate and thus your hypothesis is supported or not. It is important for your experiment to be a fair test. You conduct a fair test by making sure that you change only one factor at a time while keeping all other conditions the same. You should also repeat your experiments several times to make sure that the first results weren't just an accident. 6. Analyze your data and draw a conclusion. Once your experiment is complete, you collect your measurements and analyze them to see if they support your hypothesis or not. Scientists often find that their predictions were not accurate and their hypothesis was not supported, and in such cases, they will communicate the results of their experiment and then go back and construct a new hypothesis and prediction based on the information they learned during their experiment. This starts much of the process of the scientific method over again. Even if they find that their hypothesis was supported, they may want to test it again in a new way. 7. Communicate your results. To complete your science fair project, you will communicate your results to others in a final report and/or a display board. Professional scientists do almost exactly the same thing by publishing their final report in a scientific journal, or by presenting their results on a poster or during a talk at a scientific meeting. In a science fair, judges are interested in your findings regardless of whether or not they support your original hypothesis. The aim of scientific studies is to test theories or hypotheses, provide evidence for or against them, and ultimately advance our understanding of the natural world. Scientific studies are typically published in peer-reviewed academic journals and subjected to scrutiny and criticism by other experts in the field before they are accepted as valid contributions to the scientific knowledge base. Some key skills involved in scientific learning include critical thinking, problem solving, data analysis, and effective communication of results. It is important to approach scientific learning with an open mind and a willingness to question assumptions and revise ideas based on new evidence. Thanks for watching.